right, today we're going to look at two final things with these absolute value functions, and then we're going to wrap up on them. And those two things are how do we find intercepts, x-intercepts and y-intercepts, and then we'll talk about domain and range, and we'll call it a day. All right, let's start by talking about the intercepts for an absolute value function. Every function should have a y-intercept, and when we talked about linear functions, we talked about substituting in x as 0 to find the y-intercept, and then y as 0 to find the x-intercept. And there's no difference here with an absolute value function. We always do any kind of intercepts the same way. So let me see if I can find an x-intercept for this function. Before I do that, though, just a reminder that I know the vertex of this function is going to be located here, comma here, the opposite sign of this, comma this number. So my vertex should be at -3, comma 4, going back to what we talked about yesterday. So let me put that point on the graph. -3, comma 4 is right here. That's the vertex, the turning point of this function. And I also know, based on the fact that this is a -2, that this function should open downward somehow. I'm not sure exactly how, but it is going to open down. All right, let me algebraically find those points. So I'm going to substitute in 0 for x, and if I put in 0 for x and solve for y, I have y equals -2 times the absolute value of 0 plus 3 plus 4. That's -2 times 3 is -6 plus 4. Remembering my order of operations, I do inside the absolute value first. That grouping symbol gives me -2. That tells me when x is 0, y is -2. That means I have a y-intercept right at that point 0, -2. I also know these absolute value functions are symmetric, so I know it's going to go kind of up like this and down like this. There should be a point, a kind of a mirrored point over here somewhere. So I can kind of sketch that in. What I'm looking for specifically, though, here is the y-intercept. I'm sorry, the x-intercepts next. I want to know exactly where they are. So I'm going to do what I did before, and I'm going to put in 0 for y and see what happens. If I substitute 0 for y, I have 0 equals -2 absolute value of x plus 3 plus 4. And now look at this. I've got exactly one of those absolute value equations that we've been solving for months now. I know how to do this. I'm going to isolate the absolute value first by first subtracting that 4 from both sides. That gives me -2 absolute value of x plus 3 equals -4. And then I'm going to divide by the -2 on both sides, which gives me absolute value of x plus 3 equals, now that's a +2. And I know how to solve these absolute value equations. I do my two cases. X plus 3 equals 2, and x plus 3 equals -2. And I solve by subtracting 3 from both sides. That gives me x equals -1, and x equals -5. So there are 2 times here where the y value is 0, when x is -1 and when x is -5, which puts me right here and right here. And that gives me a beautiful picture of what my absolute value function looks like. All right, so that algebra that we did earlier in the year ties in here as well. We know how to solve these absolute value equations. We can use them to find those x-intercepts, which helps to give us a nice picture of the graph. So let's try that one more time. Here's a new function, y equals absolute value of x minus 3 plus 1. My vertex in this case should be at +3, +1. Again, the opposite sign of this is my h. This is my k. Vertex, that turning point is found at hk. So 3, 1 is right here. And I'm going to use a little bit of my intuition combined with my knowledge here. I noticed that the coefficient of that absolute value is not written in. That means it's a 1. It's a +1, which means that this function should open up. Let's see what that can tell us. Well, let me find, again, my x and y-intercepts. Find the x-intercept by letting y be 0. I find the y-intercept by letting x be 0. Let me find that y-intercept first. If x is 0, y will equal absolute value of 0 minus 3 plus 1. That's 3 plus 1 should be 4. My y-intercept is at 4. And again, there should be a mirror image point on the other side. If you can kind of visualize it, we know where that's going. Well, what does that tell me about the x-intercepts? Based off this graph and what I know, there should not be any x-intercepts. Let's see what that means algebraically to us. So we would do the same thing algebraically to find the x-intercepts here that we did in the last problem. Let's let that y equal 0. 0 equals absolute value of x minus 3 plus 1. And let's try to solve and see what happens. My first step would be, again, isolate the absolute value by subtracting that 1 from both sides. So I have absolute value of x minus 3 equals negative 1. And if I remember back to when we studied those absolute values, if the isolated absolute value is negative, I had no solution. That tells me no x-intercepts. So that combined with this picture that we've already sketched, it all makes sense, right? It all comes together. There aren't any x-intercepts. That idea of no solution makes sense here. Sometimes there is not a value that's going to make the y value 0. Remember that we can also solve this equation. I would get, if I set up my two cases, x minus 3 equals negative 1 and x minus 3 equals 1. And I can find two values for x that will solve these equations. X would equal 2 and x would equal 4. But again, if I substituted those values back into the original absolute value equation, right here, yeah, right here, I'll plug it in here. If x is 4, absolute value of 4 minus 3 is 1, its absolute value is not negative 1, it's positive 1. So we can find equations that look like they work, but if we check them, we find they don't work. So again, we combine those ideas that we've been talking about all year into a graphical situation, which is really what algebra and algebra 2 and trig are all about, is combining all these ideas together, the algebra, and then putting them on the graph. All right, so solve these next few slides, and then I'll talk to you soon.